In this video, I will talk about integration by substitution. This is one of the very useful methods of finding integrals of functions. And this can be applied for only a particular type of function, which can be written as f of g of x times g prime of x. So this part is the composition part. And here is the derivative of the inside function of the composition part. So we should be able to write a function as a composition times the derivative of inside of the composition. So let me mention that here. So this is the composition part. We have f and g composed. And we must have right next to it the derivative of inside of the composition part. Then only we can apply this method, integration by substitution. Letting g equals u, the formula becomes integral of f of u equals the antiderivative of f plus constant. Okay, let's look at this example. So here we have x squared plus 3 to 5 as the composition part. So this is the composition part times 2x. So we say 2x is the derivative of x squared plus 3. So we must be able to do integration by substitution. So let's just try it. So we let u to be the inside of the composition part, inside function of the composition part. So we let u to be x squared plus 3. Now we want to write everything in terms of u. We want to write the whole integral in terms of u. For that, we have to find dx in terms of du. So we get du by dx equals 2x, doing the derivative of x squared plus 3. And then from here, I can say dx equals du over 3. So basically, we are sort of separating du and dx for the purpose of finding dx in terms of du. So we get dx equals du over 3 when we solve for dx. So this gives dx equals du over 2x. So here we are sort of separating du and dx for the purpose of finding dx in terms of du and solving for dx. That will give us du over 2x. So now we are ready to do the substitution. Therefore, the integral becomes, so we are letting x squared plus 3 to be u. So we have u to 5. We replace x squared plus 3 by u. So we get u to 5 times 2x. I'm going to keep 2x as it is, times dx. dx, we found that to be du over 2x. And looks like 2x gets cancelled out very nicely. So this will give us u to 5 du. And we can find the antiderivative of this function using this formula over here. With n equals 5, we get u to 5 plus 1 over 5 plus 1 plus constant. So this is the antiderivative of u to 5. And I can go one step further, simplifying. U to 6 over 6 plus constant. Now finally I can write the function in terms of x back, because u is x squared plus 3. So we have x squared plus 3 to 6 over 6 plus constant. So this is the antiderivative of x squared plus 3 to 5 to x. So let's look at the next example we have here. So we want to find the derivative of x to 5 times x to 6 plus 3 to the power 12. So in this case, this part is the composition part because we have x to 6 plus 3, a function to the power 12. So this is a function of a function. So this is the composition part. And to determine if we can apply integration by substitution, we try to see if the derivative of inside is there in the front. Just by looking at it, derivative of x to 6 plus 3 is actually 6x to 5, but we have just x to 5. So it's off by a constant multiple, but a constant multiple we can always move around. So the integration by substitution should work. And if you are not sure if it will work or not, you can start by letting u equals the inside part. And then as you work along, you will see if it's not going to work. So you will get into some problem if it is not going to work. So we start by letting u equals x to 6 plus 3. Then just doing the derivative, we get du by dx equals 6x to 5 because we want to express dx in terms of du. That gives us dx equals du over 6x to 5. So now we are ready to do the substitution. So therefore, the integral is, I'm going to put x to 5 as it is, times, for this part, x to 6 plus 3, we are letting that to be u. So we have u to 12. And dx is simply du over 6x to 5. So now it looks like this x to 5 gets canceled out. And I can pull the constant 1 by 6 out. Then we are left with u to 12 du. Again, I can find this integral using this power rule formula we have. So this will give us 1/6 over here times u to 12 plus 1 over 12 plus 1 plus constant. So I'm going to go one step further here, simplifying this in terms of u. So we have 1/6 u to 13 over 13 plus constant. Now we can write down, we can replace u with x to 6 plus 3 so that we have the final form in terms of x. And the constant part, we have 1/6 times 1 by 13. 6 times 13 is 78. So we get 1 over 78. And u to 13 is x to 6 plus 3 to the power 13 plus constant. So this is the antiderivative of x to 5 times x to 6 plus 3 to 12. Let's look at the next example now. So here we have the function 2x squared times sine 6x cubed plus 10. Again, here we note that this part is the composition and this is the inside function of the composition part. So we start by letting u equals inside function. Let u equals 6x cubed plus 10. Now we want to express dx in terms of du. So we need to find the derivative of u with respect to x. This will give us 18x squared. And that implies dx equals du over 18x squared. So therefore, the integral becomes 2x squared. I'm going to write 2x squared as it is. Sine of u we are letting this whole thing to be u. And dx is du over 18x squared. Okay. We can simplify this little further because we can cancel out x squared from top and bottom. And 2 over 18 we can cancel out to get 9 over here. So we are basically left with 1/9 of integral of sine u with respect to u. So this becomes 1/9, and you see the integral of sine x is given by this formula here. So this will be cosine u plus constant. Now finally we can just replace the expression for u back in terms of x. So we'll get 6 x cubed plus 10 plus constant. This is the integral of this function, 2x squared sine 6x cubed plus 10. So let's look at the next example. We have x to 8 times square root of x to 9 plus 3 as our next example. Again, here the composition part is this one. So we start by letting u equals inside of the composition part, which is x to 9 plus 3. Then we get du by dx equals 9x to 8, the derivative of x to 9 plus 3. Then this implies dx equals du over 9x to 8. So now we are ready to do the substitution. Therefore, this integral becomes x to 8 times square root of u, because we are letting this inside part to be u. And dx, we found that to be du over 9x to 8. Looks like we can cancel out a few things here. So x to 8 and x to 8, that goes away. So we are left with 1/9. I'm going to bring that outside the integral. Square root of u du. And I can write that square root of u as u to 1/2 so that I can apply this rule, integral of x to n. So this becomes 1/9 times u to 1/2 plus 1 over 1/2 plus 1 plus constant. I'm going to go up here. So we get 1/9 times u to 3/2 over 3/2 plus constant. So this dividing by 3/2, I can flip that and make that multiplied by 2/3. So we'll get 2/27 as the constant part. And for u, now I can replace the expression of u in terms of x back here so that we have the final answer in terms of x. So x to 9 plus 3 to the power 3/2 plus constant. So this is the integral. Next, we will look into how we can use the integration by substitution method for definite integrals. So basically, for definite integrals, we need to change the limits of integration. So a will become g at a and limit b will become g at b. Otherwise, the rest of the process will be very similar. So when we change the limits like this, our whole integral, including the limits, will be in terms of u. So now let's look at this example. Here we are trying to find integral of sine x over cosine 4x. cosine to the power 4x from pi by 4 to pi by 3. So we start by letting u equals inside of the composition part. Here the composition part is this one, and we can look at this as cosine x to the power 4. So that means the inside of the composition part here will be cosine x. And then we want to express dx in terms of du. So we get du over dx equals negative sine x. The derivative of cosine x is negative sine x. Then this implies dx equals du over negative sine x. Done with expressing dx in terms of du. Now this is definite integral, so we also need to find the limits for u. These pi by 4 and pi by 3 are limits for x. Now we need to find limits for u. So that we can just do by looking at the function u in terms of x. So we have when x equals pi by 4, then u would be cosine of pi by 4 because u is cosine x. And we know cosine of pi by 4 is square root 2 over 2. Similarly, when x equals pi by 3, then u equals cosine of pi by 3. And we know cosine of pi by 3 is 1/2. So to get these values, you can either use your calculator or a unit circle, whatever is available to you. So now we are ready to do the substitution. So this becomes integral from, so now our new limit of integration are root 2 by 2 to 1/2. And then we have, I'm going to write sine x as it is, divide by cosine 4x, so that I can write as u to 4 because we are letting cosine x to be u. And then dx is du over negative sine x, like we have here. So it looks like I can cancel out sine x from top and bottom. So sine x goes away, but we are left with that negative sign. I'm going to pull that negative sign all the way to the front. So we get negative root 2 by 2 to 1/2. And then inside we are left with 1 over u to 4 du. I can rewrite this as negative integral from root 2 to 1/2, root 2 by 2 to 1/2, u to negative 4 du. Okay, now we are ready to do the integral because we can simply apply this formula. Formula for x to n with n equals negative 1/4. I'm going to write that over here. So we have negative u to negative 4 plus 1 over negative 4 plus 1. And we are evaluating this from square root of 2 over 2 to 1/2. Then this becomes, let's simplify this expression a little bit further before plugging in the values. So we have u to negative 3 over negative 3. And we are evaluating this from square root 2 over 2 to 1/2. I'm going to go one step further simplifying this. So this becomes, now I can pull that 1/3 out and make that 1 by 3. So we have negative and negative 3, so 1 by 3. And for u to negative 3, I can just write as u cubed. So, and we are evaluating this from root 2 by 2 to 1/2. Okay. So now we are ready to evaluate this. So when u is 1/2, I can pull that 1/3 out. So when u is 1/2, we have 1 over 1/2 cubed. And when u is square root 2 over 2, we have 1 over square root 2 over 2 cubed. So now the rest is just simplifying this expression here. So I'm going to erase this part on the top so that we have some space. So we get 1/3 in the front and 1 over 1/2 cubed. That would be 1 over 1 by 8 minus 1 over root 2 over root 2 cubed. So root 2 cubed will be 2 square root of 2, because root 2 squared is 2, and then we have root 2. So that divided by 8. So now I can flip both of these denominators, and the first one becomes 1 times 8 over 1, which is simply 8, minus the second one becomes 8 over 2 root 2. And if you like, you can combine them, or maybe you can factor out 8 and write this as 8 over 3 times 1 minus 1 over 2 root 2. So this is the value of this integral. Next, let's look at this example. Here we are integrating x squared plus 3 to 5 times 4x from x equals 1 to x equals 2. So again, the first thing to notice here is this is the composition part, and we want to let the inside of this part to be u. So we let u equals x squared plus 3. So with this, we'll try to write the whole integral in terms of u. So then du by dx here will be 2x, which implies dx equals du over 2x. And we also need to change the limits. So when x equals 1, then u equals 1 squared plus 3, which is 4. And similarly, when x equals 2, then u equals 2 squared plus 3, which is 7. So these will be our new limits of integration. So now we are ready to convert this integral in terms of u. So our new limits of integration are 4 and 7. So we put them down. And we are letting x squared plus 3 to be u. So we have u to 5 times 4x. I'm going to put 4x as it is, since I don't see any obvious way to replace that. Then dx we know is du over 2x. So dx is du over 2x. Looks like we can cancel x out. So that x and that gets canceled out. So we are left with, and I can also divide 4 by 2, so that will give us 2. So I'm going to bring that 2 all the way to the front. So it becomes 4 to 7 u to 5 du, which is a very nice integral. And we can integrate that simply by using this formula. So we get 2 times u to 5 plus 1 over 5 plus 1 evaluated from 4 to 7. So this becomes 2 times u to 6 over 6 evaluated from 4 to 7. And 2 over 6 is 1/3. I'm just going to pull that out in the front. Then u to 6 will be 7 to 6 minus u to 6. Next will be 4 to 6. So we have 7 to 6 minus 4 to 6. Now you may need to use your calculator to get 7 to 6 minus 4 to 6. So when you put all this in your calculator, it should come out to be 37,851. This is the value of this integral. This is the next example we want to work. So here we want to find the integral of x to 8 times square root of x to 9 plus 3 from x equals 0 to x equals 1. Again, the first step is to identify the function we want to substitute by u. So you want to let u to be inside part of the composition. So here I would say this part is the composition and inside is x to 9 plus 3. So I'm going to let u equals x to 9 plus 3. Now we want to write dx in terms of du. So for that we need to find du by dx, which will be 9 x to 8. So this simply implies dx will be du over 9 x to 8. We also need to find new limits. These limits are for x. We need to find limits for u. So when x is 0, then u is 0 to 9 plus 3, which is 3. Similarly, when x is 1, the upper limit, then u is 1 to 9 plus 3, which is 4. So these will be our new limits of integration. So now we are ready to write this integral in terms of u. The limits of integration are 3 to 4. And I'm going to leave x to 8 as it is for now. And then we have square root of x to 9 plus 3, but we are letting x to 9 plus 3 to be u. So I'm just going to put u over there. And we found that dx we can replace by du over 9x to 8. So looks like x to 8 gets canceled out. And then we are left with 1/9. I'm going to pull that 1/9 all the way to the front. Integral from 3 to 4 of square root of u du. So to evaluate this integral, I can write square root of u as u to 1/2. We have du. So now I can just apply this formula, the power rule, to get the integral of u to 1/2. Then we get 1/9 integral. We have u to 1/2 plus 1, which is 3/2, over 1/2 plus 1, which is again 3/2. And then we are evaluating this from 3 to 4. Okay. So we are ready to evaluate this. I'm going to do that up here. I'm going to do that up here. So I can pull this 3/2 out, and multiply that to 1 by 9, that will give us 2 by 27. 1 by 9 times 2 by 3 will be 2 by 27. Then here I can put down what we get when we plug in the values 4 and 3. So when you plug in u equals 4, we get 4 to 3 by 2, minus when you plug in u equals 3, we get 3 to 3 by 2. So I can go one step further and write this as, so 4 to 3 by 2 will come out to be, so let me show that over here. 4 to 3 by 2 is, so 4 to 3 by 2 you can write as 4 times 4 to 1/2, which is 4 times square root of 2. So 4 to 1/2 is simply 2. So this comes out to be 8. And also for 3 to 3 by 2, I can write that as 3 times 3 to 1/2. So 3 to 1/2 is just a square root of 3. So I can write this as 3 square root of 3. So we get 8 minus 3 square root of 3. So this is the value of this integral. 2 over 27 times 8 minus 3 square root of 3. This is the next example we want to work on. Here we want to find the integral of x to 8 times e to x to 9 plus 3 from 0 to 1. So again, the first step is to notice that u will be x to 9 plus 3, because that is the inside part of this composition. So the composition part is e to x to 9 plus 3, and the inside function is x to 9 plus 3. So now we want to express dx in terms of du. So for that, we need to find the derivative of u with respect to x, du by dx, and that will be 9x to 8. This implies dx equals du over 9x to 8. We also need to change the limits. So when x equals 0, which is the lower limit for x, then u equals 0 to 9 plus 3, which is simply 3. And similarly, when x equals 1, then u equals 1 to 9 plus 3, which is 4. So these will be our new limits of integration. So now we are ready to write this integral in terms of u. The lower limit is 3 and the upper limit is 4. I'm going to write x to 8 as it is for now, hoping it will get cancelled out later. And then we have e to u, because we are replacing x to 9 plus 3 by u. Then dx, we wrote that in terms of u as du over 9x to 8. It looks like x to 8 gets cancelled out like that. So we are left with 1/9 from here, an integral from 3 to 4 of e to u du. So to get integral of e to u, we can just apply this formula. Then we get 1/9 e to u evaluated from 3 to 4. So this becomes 1/9 e to 4 minus e cubed. So this is the value of this definite integral. This is the last example we have in this video. So here we want to find integral of x squared over 5 minus x cubed from 2 to 4. The first step is to notice that u is 5 minus x cubed. So once you have that, then you want to you want to find derivative du by dx so that you can express dx in terms of du. Then this will give us dx equals du over negative 3x squared. Solving for dx. We also need to write the limits in terms of u because these limits are for x. So when x is 2, I can say then u equals 5 minus 2 cubed, which is 5 minus 8. So negative 3 is the lower limit. Similarly, when x equals 4, I can say that u is 5 minus 4 cubed, which is 5 minus 64, so negative 59. So this will be the upper limit of integration. So now we are ready to write this integral in terms of u. So this becomes integral from negative 3 to negative 59. I'm going to leave x squared as it is for now, hoping it will get cancelled out later. And 5 minus x cubed is simply u, because we are letting u to be 5 minus x cubed. And dx, we found that to be du over negative 3x squared. Looks like we can cancel out x squared very nicely. And then we get, so this will give us, I'm going to pull that negative 1/3 out. Then we are left with 1 over u du. So now we just need to use one of the formulas we have available to get the derivative of 1 by u, and we'll be using this formula. So this becomes 1/3 natural log of u, and we are evaluating this from negative 3 to negative 59. Now this becomes negative 1/3. So we have natural log of absolute value of negative 59 minus natural log of absolute value of negative 3. Then we get negative 1/3 natural log of 59 minus natural log of 3. And then if you like, you can combine these two logs as negative 1/3 natural log of 59 by 3 using the log rules. So this is the value of this definite integral.